Everyone, and welcome back to the ACSL Ultimate Review. This is part of the Road to Gold playlist where I'm going to be covering all the material that you will see on your ACSL multiple choice, whether you are a junior, senior, or intermediate division competitor. So this is episode 2, so I'm going to be going over the 3 topics that you will see on your multiple choice, whether you're in contest 2. So let's begin with the first topic, Lisp. So in ACSL, Lisp is primarily a language that is used to work with lists or performing the nested math operations. So to the left, you're going to see a table I got from the ACSL wiki, which goes over all of the methods that you are responsible for knowing that will appear on the ACSL multiple choice, whether that is adding, subtracting, dividing, squaring, the numbers. And as you can see, some of them can take in more than one parameter. For example, the add and multiplication methods can take in as many parameters as needed because this is a operation that can be performed on an unlimited number of values. But then there's also operations such as the square and the exponent operation, which require a set number of values. So square would only need 1 and exponent needs 2. So those are typically the number of parameters you will see for those operations on your contest. Now, to the right is a list of different list operations for ACSL. So the most important ones that you should know is CAR, CDR, setQ, and reverse. So CAR is going to grab that first element of a list, but you need to be very careful with how this works because you need to watch for nested parentheses. It's not just going to take the first element of a list, it takes the first element in the base list. So what I mean by that is if there's several nested lists, it's going to take the very first one. So that is something that you will see when we go over a few problems, and that will make more sense in just a second. So CDR takes everything but the first element, so it's kind of like the opposite of CAR. So it's getting rid of that first part of the list. SetQ is what is going to, it's essentially an equality operator or an assignment operator in Lisp where you are setting that variable z in this case equal to that list right here. So reverse is going to switch the order of a list. Now notice it's not just going to be like list A is blue, white, red, right? It's only switching the most outermost list element. So red, white, blue is a nested element, so that's treated as one whole element that's going to be moved to the end of a list, which is why red, white, blue remains in that same order. But a list is not nested in any parentheses, so they're all 3 separate elements, and that's why they are rearranged in the reverse example. So there is actually a condensed version for writing Lisp CAR and CDR, So, for instance, take this CDDDAR, which this means that we're using CDR 4 times and we're using CAR once because the D here is listed 4 times and A is listed 1 time. So it's simply a way to condense it. In ACSL, you might be able to see a condensed version of Lisp being used, but you might also see something like this where it's the expanded version. It goes both ways, and you should be comfortable with identifying and translating both back and forth. So now for some practice. For this expression, you start here with the innermost parentheses, so exponent 2, 3, sub 4, 5, and add 5, 11. Those are the 3 innermost operations. So when we perform those, we're going to get 8, -1, and 16. And then our next operations are multiply and square. So when we perform the multiplication here, we're going to get -128. And then when you square 5, you're going to get 25 as your result. So then you add these 2 final values and you get your answer of -103. Next, this is going to be how to work with lists. So here we're setting set Q A, so A is now going to be equal to that entire list. And then we're going to use this new abbreviation that we learned to solve this one. So we see CADDADR, so that's going to be CAR, CDR, CDR, CAR, CDR on A. So let's see, CDR grabs everything but that first element here. So what would that be? So our first element here is 5, 3. So this is in parentheses, which is why it's treated as that a whole element. So we're not just going to remove 5, you're actually removing everything in that group of parentheses that is treated as an individual element. So when that gets removed, our next operation is CIR. So CIR is going to take that very first element. So again, you have to pay attention to the parentheses here. So it's going to grab that entire middle area because it's nested in parentheses. Next, CDR is going to get rid of that very first element. So that is going to be 4. Next, we're running CDR again, so we're getting rid of another element, so that's going to be 3 that gets cut. And lastly, we're taking CAR. So I know you may believe that this is going to return 9. It's not actually going to return 9, it's going to return 981. And the reason for this is because we see that this list is actually nested in 2 different parentheses. So before that, when we remove 3, we're going to have 2 parentheses around that 9 to the left of it, and also we're going to have 3 parentheses to the right of 1 there. So it's a list, and then there's another list inside of a list. So when we're grabbing that first element, we're taking that entire list that's nested in that outer list, which is why we're only getting rid of a level of parentheses, but we are not taking the actual values inside of that nest. So that's why this method would return 9, 8, parentheses 1. So, and now if you were to call CAR again, it would return 9 because we only have 1 layer of parentheses surrounding the list here. So the next operation that's important to learn here is prefix, infix, and postfix. So infix is when the operand is between 2 values. This is what we are used to. So when we're adding 2 and 3, we would write 2 plus 3. 2 and 3 are the 2 values that are being added together. So prefix does it a little differently, where the operand comes before the 2 values it's being performed upon. So in this case, the plus sign would go before 2 and 3, which would translate to 2 plus 3 in infix. And postfix is where the operand goes after the 2 values. So it would be 2, 3, and then the operand, so plus. So it's a little unintuitive sometimes, but it is very simple to get the hang of once you get comfortable with seeing these and performing some problems with these. So for a second, let's take a look at this first section, evaluate. So it's asking us to evaluate this prefix expression. So it's usually going to clarify whether the expression's prefix or postfix. You'll usually be able to tell in a postfix expression, you'll see all the operands kind of clumped towards the end of the number chain, and in a prefix expression, you'll see them more towards the beginning, right here. So that's how we know it's a prefix. So let's start with evaluating the ones with the most with the innermost operands. So right here we see a multiplication symbol. It's directly to the left of 2 numbers, which means that this is one of the first steps that we have to perform to simplify the expression. So 2 times 3 right here, 6. Write that down. Now we see divided, 10, and 5. So that's how we know it's going to be 10 over 5. That's going to be 2. Next, we have 2 3 times again, so that turns into a 6. So this becomes our new operand, negative, plus, 6, 2, and 6. Now, our next expression that we can simplify is plus 6 and 2, right? Because that's the operand we have to the left of 2 digits immediately. So that way we're going to be adding 6 and 2, and you get 8. So then we have negative 8, 6. So that's how we know it's going to be 8 minus 6. So our final result here is 2. Now, if you want to convert from the expression, you simply do the same thing, except instead of substituting a 6, you're going to substitute the equivalent infix expression or postfix. So here I convert it to infix, and then I go ahead and convert it to postfix. So I wouldn't recommend doing this. If you are converting prefix to postfix, you can directly switch it to postfix. You don't have to go in between and convert it to infix unless you find that easier for you. But I did it in this case to demonstrate how the expression would look. So 2 times 2, 3 here. Change it to 2 times 3. We do the same for our other 2 that previously we solved, but now we're just writing the infix version, and then we're moving our minus and plus sign in between here. So this would be the infix version of this expression. And then we have our postfix expression, where we're changing this infix value to its postfix equivalent, and then we're shifting our minus and plus signs to where they need to be. So this is equivalent to the postfix. The next topic that's covered on ACSL is bit string flicking. So this usually involves solving for a string, or you're going to be evaluating the final state of a binary string with 0s and 1s. So these here are the primary operands that you need to know: not, and, or, and, XOR, and also L shift, L circle, and right circle here. So this is an example of solving for a string here. So let's see. So we're going to start off with our innermost string. So we have right circle 11001. So that means that we're drawing an arrow. This one should end up in the position of this 0. So we're shifting it, and this is how it ends up looking, 00111. Now we have XOR, and let's left shift this to see what the value is. So left shift 1, and remember in a left shift the value just gets truncated. So we have 01100. That 1 does not come back around because it's a shift, not a circle. So now we're doing exclusive OR here. So if the two values are the same, we're putting a 0, and if the two values are different, we're putting a 1. So here we see 0 and 0 are the same, 0, 0, and 1 are different, 1, 1, and 1 are the same, 0, 1, 1, 0, 0, both are different, so we have a 1, 1 here. So next we see this AND right here, and we're going to perform the AND operation on this string and this output. So 0 and 1, that's 0, 1 and 1 is 1, 0 and 1 is 0, 1 and 0 is 0, and 1 and 1 is 1. Next, we have to perform a right shift on this final string, an L shift, apologies. So we're going to shift everything, truncate it. So L shift would shift 1, 2. This one would become in the middle, and because this one would get truncated, our final string is 0010, which is what we have up here as our answer. Next, we're going to go over how to solve for an X string. So sometimes you'll be given an X variable and it represents a string that's going to equal some sort of operation. So what you begin is you substitute X for A, B, C, D, E, and then you perform the operations as normal. So let's see, we have A, B, C, D, E, or our circle 00110. So I actually went ahead and performed the R circle prior, so we have this would right circle 2 for the string would be 10001. We're doing OR A, B, C, D, E. So we know that OR of any value, if one of them is 1, it's just going to automatically be 1, which is why for A and E it doesn't really matter what they are. So that's why we just place a 1 there. Now B, C, D, it does matter because the rest of the string's values are 0. So if B, C, D are 1, then the final string will be 1. Otherwise, it's going to be 0. So which is why we substitute our B, C, D variables in there. Now it says right here we're performing a left shift. So that 1 gets truncated, a 0 gets placed there. So we have B, C, D, 1, 0. And it's equal to the not of that string right there. So let me just perform that not operation, 11001. The not of that is 00110. So now we're saying that those two strings are equal to each other, which means that B is equal to 0, C has to be equal to 0, and D equals to 1. Now A and E are not in our equation. That just means that they're not really relevant and that they can be anything, and that it doesn't matter because we get rid of them anyways. So that's why we're using that little star symbol, and that represents anything, any value. So that's why our final string is going to be A, which is a star, 001 for B, C, D, and then another star because E can represent any value. So that would be our final answer for that problem. So that's all I have for contest 2 today, so I highly recommend looking at the ACSL wiki page. There's a lot of past contest problems, and there's a lot of additional resources that you can look into, and I'm going to be posting a contest 3 video sometime in the next week, so you should check that out too. Thank you.